So we are going to learn how to obtain the adjoint of a 3 by 3 matrix. Okay, so let us use the example A is given by 3, negative 3, 4, 2, negative 3, 4, 0, negative 1, 1. So to obtain the adjoint, you will need something called the cofactor for each and every entry in the matrix. So let's start by the first entry, which is 3. So we say the cofactor of 3. So the cofactor of 3 is obtained by taking negative 1, then you add the row number and the column number to get the power. So 3 is in row 1, column 1, so that is 1 and 1, so that is 1 plus 1. Then after obtaining that, you get the small matrix there. If you cover the first row and the first column, what is left there is negative 3, 4, negative 1, 1. So that will be, that is negative 1 raised to power 2, that is 1. Okay, so it does not affect the whole thing. So let us get this determinant. This is negative 3 times 1 minus 4 times negative 1. That is the same as negative 3 plus 4, which is 1. So the cofactor of 3 is 1. Then we do the same for the next. The next is negative 3. So negative 3 is in row 1, column 2. So that is the power 3. So that is 1 plus 2. Then the small matrix that is left when we cover its row and its column, that will be 2, 4, 0, 1. 2, 4, 0, 1. Okay, let's get that. So because the power is odd, the negative will hold. So we have negative of 2 times 1 minus 4 times 0. So that will be the negative of 2 times 1 is 2 minus 0. So that is negative 2. So the cofactor of negative 3 is negative 2. So let us go to the next one, which is 4 there. So the cofactor of 4 is given by negative 1 raised to power, it is in row 1, column 3. Row 1, column 3. Then when you cover its row and its column, you are left with this small matrix there, which is 2, negative 3, 0, negative 1. So because 2 plus 3 is 4, that is even, so the negative will not hold. So we have 2 times negative 1 minus negative 3 times 0, negative 3 times 0. So that is negative 2 plus 0 or minus 0. Okay, so negative 2 minus 0, that is still negative. That is still negative 2. So let's go for the cofactor of the next one. So the next one is 2. So for the cofactor of 2, this is negative 1. Negative 2 is in row 2, column 1. So that is 2 plus 1. Then when you cover its row and its column, you're left with the matrix negative 3, 4, negative 3, 4, negative 1, 1, negative 1, 1. Okay, so because the power is odd, that is 3, the negative will hold. So we have negative, then we have negative 3 times 1 minus 4 times negative 1, 4 times negative 1. Okay, so that will be negative of, we have negative 3 plus 4. Negative 3 plus 4. That will be, okay, that will be 1. That will be negative 1. Okay, so the next number, the next entry is negative 3. This one here, we're going to have negative 1 there. Then its row, it is in row 2, column 2. That is 2 plus 2. If you cover its column and its row, you're going to have 3, 4, 0, 1. 3, 4, 0, 1 there. So that is equal to, so because the power is even, the negative will not hold. So we just left with 3 by 1 minus 4 by 0. That will be 3 minus 0, which is just 3. Okay, then the cofactor of the next one, which is 4, negative 1. So 4 is in row 2, column 3. That is 2 plus 3. Then when you cover its row and its column, you're left with 3 negative 3 and 0 negative 1. 3 negative 3 and 0 negative 1. So because the power is odd, the negative will hold. So we have a negative. Then we look at that determinant, 3 by negative 1 minus negative 3 by 0. Negative 3 by 0. So here you have the negative. Then in there we have negative 3 minus 0. Negative 3 minus 0. Negative times negative, that will be positive 3. Then the next number is 0. Let's get the cofactor of 0. So we have negative 1. 0 is in row 3, column 1. Row 3, column 1. So we're going to have 3 plus 1. And then when you cover its column and row, you're left with negative 3, 4. Negative 3, 4. So because the power is even, the negative will disappear. So we are left with negative 3 by 4 minus 4 by negative 3. 4 by negative 3. So here we have negative 12 minus negative 12. So minus is plus. So negative 12 plus 12 is 0. Okay, then the next number is negative 1. So we have negative 1 raised to power. So negative 1 is in row 3, column 2. Row 3, column 2. So when you cover its row and column, you're left with 3, 4, 2, 4. 3, 4, 2, 4. So because the power is odd, the negative will hold. So you have negative of 2 times 4, not 2 times 4, 3 times 4 minus 4 times 2. 4 times 2. So you have negative of, that is 12 minus 8. 12 minus 8. So 12 minus 8 is 4. Then there's a negative, so that is negative 4. Then finally, the cofactor of 1, this last one here. So you have negative 1 raised to power. It is in row 3, column 3. Okay, so row 3, column 3. Then when you cover its row and column, you're left with 3 negative 3, 2 negative 3, 2 negative 3. So because the power is even, the negative 1 will disappear. So we are left with 3 times negative 3 minus negative 3 times 2. Negative 3 times 2 there. So this is negative 9 minus negative 6. So that is negative 9 plus 6, which is negative 3. So after you have obtained them, you write them in that order. So the adjoint of the matrix A will be 1, negative 2, negative 2, 1, negative 2, negative 2, negative 1, 3, 3, negative 1, 3, 3, 0, negative 4, negative 3, 0, negative 4, negative 3. And that is the adjoint of the matrix A.